Hey guys, sorry for being so late. I hope we still get this. I'm going to send out an email to everybody. But if we have y equals x squared minus 6x plus 9, then what we actually have is a parabola. We know it's going to be a parabola shaped, and it is a quadratic function. The quadratic function is the form of y equals ax squared plus bx plus c. Our quadratic function here, if we want to make a table, we can do this, and we can start with negative, say, negative 2. If I plug in a negative 2, I get negative 2 squared minus 6 times negative 2 plus 9. Let's see if Miss Baker can do some math. Negative 2 squared gives me 4. Negative 6 times that negative 2 gives me plus 12. And then plus 9 gives me a great big old answer of 25. Well, I can't show that, can I? That's not going to work. 25. If I plug in negative 1, then I get negative 1 squared minus 6 times negative 1 plus 9. So my first coordinate, was negative 225. Can't show that. My second coordinate is negative 1, and negative 1 squared is going to give me 1. Negative 6 times negative 1 is going to give me positive 6, and then plus 9. So we're still huge, right? We're at 16. I don't have 16 anywhere. So let's keep going. What happens if I plug in 0? Well, that's going to give me 0 squared minus 6 times 0 plus 9. Well, 0 and 0, I can graph 0, 9, so yay! 0, 9 is going to be the first point that I see. Let's see what happens if I plug in a 1. I'm going to get 1 squared minus 6 times 1 plus 9. Well, 1 squared gives me 1 minus 6 plus 9 means that I have, if I put my 1 and my 9 together, that's what my brain wants to do. I get 10, and 10 minus 6 is 4. So we get 1 comma 4. We go over 1 and up 4. What happens if I put in 2? I get 2 squared minus 6 times 2 plus 9. 2 squared is going to give me 4. So my 4 and my 9 give me 13. And then negative 6. So 4 minus 12 plus 9. These two give me 13 minus 12. So I hope you saw that my brain got 2 comma 1. So go over 2 and up 1. I'm going to have to keep going. I got to see what happens at 3. If I plug 3 in, so my x coordinate is going to be 3. Then my y coordinate, if I squeeze it right here, is going to be 3 squared minus 6 times 3 plus 9. 3 squared is going to give me 9. If I have a negative 6 times 3, that gives me negative 18. And plus 9, so 9 and 9 give me 18. Minus 18, I get 0. So 3, 0. It's starting to look like a parabola a little bit. Let's see what happens if I put in a 4. I'm running out of room. I'll squeeze the 4 up here. If I put in a 4, then I get 4 squared minus 6 times 4 plus 9. Well, 4 squared gives me 16. Negative 6 times 4 is going to give me negative 24 plus 9 is going to give me 16 and 9, which is 25. And 25 minus 24 is 1. Just to check myself, it looks like my parabola is coming down like this. If you're Anthony, you're going to guess that my next point is going to be 5, 4. I'm going to check myself. 4, 1 was the next one. And for Zach, I'm going to check myself before I wreck myself. If I have, sorry about that, Zach. Here's 5. So I get 5 squared. Well, I can't write. 5 squared minus 6 times 5 plus 9. Well, that gives me 25 minus 30 plus 9, which if I put these two together, that's 34 minus 30. So it is 4. Ah, sorry, I moved the wrong thing. There. Hopefully you can see now. So my 5, 4 is my next point. And I can keep going up. You should be able to see that your axis of symmetry runs right down the middle. That axis of symmetry is at a particular point. You can probably hear my children screaming in the background. It's going right here. And that axis of symmetry is at 3. But I can't just write 3, because that's where they get you. You've got to know that it is x equals 3. It's a line. It's not just 3, it's the line x equals 3. Let's look at one more. I'll give that for just 1 second. Take a drink of tea because I'm tired. And here's our last one. We're going to do this one together. If we have y equals 2x squared, and that's a squared, if you can't, it's kind of hard to tell. I'm going to make that a little smaller if I'm going to try to clean it up. Y equals 2x squared minus 4x plus 1. We are going to set ourselves up in a table again. And I'm just going to start at -2. I don't know where else. I think right now that's what we're going to do. We have 2 times -2 squared minus 4 times -2 plus 8. Plus 1. Well, -2 squared gives me 4. And 4 times 2 does give me 8. -4 times -2 gives me a positive 8. And then plus 1. 8 plus 8 is 16, plus another one is 17. Miss Baker has crazy. You can see that just by picking random numbers, this is kind of crazy. I don't have a 17 on here, so let's try -1. 2 times -1 squared minus 4 times -1 plus 1. Well, -1 squared gives me a positive 1. And positive 1 times 2 gives me 2. A negative times a negative gives me a positive, so that's going to be 4. Plus 1 more. 2 plus 4 is 6, plus 1 is 7. So I like that one. -1, 7. That's something we can graph. -1, 7. Over here in quadrant 2. If I plug in a 0, I get 2 times 0 squared minus 4 times 0 plus 1. So we know 0 and 0, nothing's over there. So it's 0, 1. So we're right there. I can plug in a 1. And it's 2 times 1 squared minus 4 times 1 plus 1. 1 squared gives me 1 times 2 is 2. -4 times 1 is -4. and then plus 1. You can probably hear my children running in the background. 2 minus 4 is negative 2, plus 1 is negative 1. So we have a point at 1, negative 1. I can plug in a 2, and that's going to give me 2 times 2 squared minus 4 times 2 plus 1. This is going to give me 4 times 2, which is 8, minus 8 plus 1. So we're going to come back up to 2, 1. Well, that's what we like to see. We like to see that part of the parabola. We found that bottom part. And some of you who watch this video, I'm going to give you a hint here in a minute. There was one question that I asked, and we'll talk about that in just a second. What happens if I have a 3? If I plug in 3, then I get 2 times 3 squared minus 4 times 3 plus 1. Well, 3 squared is 9, and 9 times 2 gives me 18. Then I have negative 4 times 3 gives me minus 12, and plus 1. Well, 18 minus 12 is 6, and 6 plus 1 is 7. If you are trying to tell from your axis of symmetry, then we are looking beautiful. This is what we're looking for. I hope you can see that we've just kind of been guesstimating where we should put something. And so here is my axis of symmetry. It is going, oh, that's terrible. It is going right down this middle of the parabola. And the axis of symmetry, in this case, is x equals 1. Now, I told you, if you watch the video, you're going to be one step ahead of everybody else because I'm going to clue you in on something we're going to talk about. This parabola has a lowest point, and this lowest point is called a minimum. This parabola has a lowest point, and this lowest point is also called a minimum. I'm going to pull up the notes from today in class. Looking all the way back to the beginning, our very first parabola once again has a minimum. It's a lowest point, minimum. Second parabola we did, once again, minimum. So far we've had a lot of minimums, and look what happens though. When we flip it upside down, you have a maximum. This particular parabola has a maximum, and so is this one. Here we have a maximum. So I'm going to be able to ask everybody who did their homework last night, and if you did your homework, you're going to be able to answer my minimum maximum question. I hope you have a great evening, ladies and gentlemen. I'll see you tomorrow.